Now it's on. And so, right, here's a quick recap. Whoa. Determining determinants. Zoop. Can only find the determinant of a square matrix. Identity matrix determinant is always 1. And there's the formula for a determinant. Why it said that you can show determinant by either writing DET out in front or by using straight lines around your matrix. And I use these two arrows to remember it. A times D, B times C. And then the red arrow, which is going backwards, is because the BC is subtracted. So, if we had these matrices, right? My green arrow here, this would be 8. My red arrow here would be -9. So if I would do 8 minus a -9,
17.
the determinant is 17. And what does that number do? I'm not telling you yet. It will become useful, but for now we'll just figure out how to find determinants. Okay? Second one. 6 times 6, 36. -4 times -9, 36. 36, subtract the 36, 0. Okay. Is that important? Yes. That tells me something, but it doesn't tell you anything yet. But the fact that one of them is 0, okay, we've already talked about can only find the determinants of square matrices. And matrices that have a determinant of 0 are called singular matrices. And a singular matrix does not have an inverse. Okay. Again, very elusive right now as far as what we're going to be doing with this. Formula for a 3×3 matrix. How is that for something to try to remember?
Do we have to remember that?
Well, yes and no. Yes, in that yes, you do have to know how to find the determinant of a 3×3 matrix. No, you don't need to know that formula per se. Well, I'll show you how one could remember this formula. But you know how I did the green arrow and the red arrow for the first one to help you remember it quicker? We're going to have a triple green arrow, triple red arrow one for this one. That's going to be just as easy. Okay? Now, when you have A, it's A times the determinant of what's left. When you have B, it's B times the determinant of what's left. And when you have C, it's C times the determinant of what's left. So that idea, if you hold that true, helps you remember that formula. So you could use your arrow formulas in here, and it always goes positive, negative, positive for your 3×3. Now, the straight line idea is you could rewrite, move these away, you could rewrite the first two columns, A, D, G, B, E, H, and you would have 3 diagonals that are positive. And so you would add those all up, and those ones would stay positive. And you would have 3 diagonals backwards, which you could add all up and make those ones negative. This will do the same thing as that previous formula, but I find that this is a lot easier to remember than the previous formula.
Any stats here?
No. So finding the determinant of this using that first method, we rewrite 2, 1, 2, negative 1, 2, 1. These three diagonals, so he'll get 8 plus 0 plus 4. These three diagonals, 16 plus 0 minus 2. Add them up, you would get 12 minus 14, a determinant of negative 2. Now we're going to type this 3 by 3 matrix into our calculator. So go to your calculator, second matrix, over to edit, and plug these values in. 2, negative 1, 4. 1, 2, 0, 2, 1, 2. So we've got our matrix set in there in A. Now if you go to matrix, second matrix, and you go over to math, it allows you to do a bunch of math with your matrix. The one that we're going to do right now is a determinant, so we're going to do a determinant of second matrix A. And we should get negative 2 if everything has worked out correctly. So this is not a singular matrix because the determinant is not equal to 0. One more example. And working backwards. So we would get 12 minus a negative 18, which gives us a determinant of 30. So we already saw on our calculator that we can enter in a matrix and we can find the determinant of a matrix. Right underneath it, number 2 was the T, which does the transpose. But the transpose just switches the rows and the columns, so it's usually something you don't need your calculator to do. And then the third one, we're going to use this one later, our REF. So the matrix, the determinant one, nice to be able to check your work if you can find it quickly. Okay. This reduced row echelon form later on is going to be quite nice, but we'll see what that does later.